Hello everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation using variation of parameters method. So let's get going. Problem: solve 2y double dash plus 3y dash plus y equal to e power minus 3x or 2d square y by 2d square y by dx square plus 3 into dy by dx plus y equal to e power minus 3x or 2d square plus 3d plus 1 into y equal to e power minus 3x using variation of parameters method. So we are given a differential equation of order 2. See, we are given 2y double dash plus 3y dash plus y equal to e power minus 3x, or we can write this as 2 into d square y by dx square plus 3 into dy by dx plus y equal to e power minus 3x, or we can use differential operator d and write the equation as 2d square y plus 3dy plus y equal to e power minus 3x, right? Since d equals to d by dx. Now take y common from all the terms of LHS. We'll get 2d square plus 3d plus 1 into y equal to e power minus 3x. See, all the three equations are same. Just the notation varies. Okay. Now coming to the problem. Given differential equation, y double dash plus 3y dash plus y equal to e power minus 3x. Consider as equation number 1. Now we need to write the given differential equation in standard form. So we'll make the quotient of y double dash to unity by simply dividing both sides of the equation with 2, or you can just write directly y double dash plus 3 by 2 y dash plus 1 by 2 y equal to e power minus 3x, or you can just divide both sides of the equation with 2, so that 2 gets cancelled from the first term. So if we divide both sides of the equation with 2, we'll get 2y double dash by 2 plus 3y dash by 2 plus y by 2 equal to e power minus 3x by 2. Right? 2 gets cancelled and you'll get y double dash plus 3 by 2 y dash plus 1 by 2 y equal to e power minus 3x by 2. Okay, sorry, here I forgot to write 2. We'll get the same thing. Okay, now write y double dash as d square y by dx square plus 3 by 2 into dy by dx plus 1 by 2 into y equal to e power minus 3x by 2. Now use the differential operator capital D. We'll get capital D square y plus 3 by 2 capital dy plus 1 by 2 y equal to e power minus 3x by 2. Now take y common from all the three terms of LHS. Consider this equation as equation 2, okay? Fine. Now we'll take y common from these three terms. We'll get d square plus 3 by 2d plus 1 by 2 into y equal to e power minus 3x by 2, which is in operator form. That is a given differential equation in operator form. We can see. Say f of d into y equal to some function of x. Consider as equation number 3. Now let's write the homogeneous equation of equation T. The homogeneous equation of 3 is d square plus 3 by 2d plus 1 by 2 into y equal to 0. Consider as equation number 4. Now we need to find solution to this equation 4 using the auxiliary equation, and later using the solution of homogeneous equation we'll find the general solution to our problem. So here f of d is d square plus 3 by 2d plus 1 by 2, and r of x is e power minus 3x by 2. Coming to the auxiliary equation. The auxiliary equation is f of m equal to 0, where f of m equal to, we have f of d square plus 3 by 2 d plus 1 by 2, right? Let's replace the differential operator d by m, so that we'll get f of m equal to m square plus 3 by 2 m plus 1 by 2. Now the auxiliary equation becomes m square plus 3 by 2 m plus 1 by 2 equal to 0. Now we need to find roots to this equation. Here we are having 3 by 2, right? We can write this as 2 plus 1 by 2. Here we are having two terms in the numerator and one term in the denominator, so we can split this as 2 by 2 plus 1 by 2, which gives us 1 plus 1 by 2. Just replace 3 by 2 plus with 1 plus 1 by 2, will get m square plus 1 plus 1 by 2 into m plus 1 by 2 equal to 0, or we can write this as m square plus m plus 1 by 2 m plus 1 by 2 equal to 0. Now take m common from the first two terms, we'll get m times m plus 1, and take 1 by 2 common from the next two terms, we'll get 1 by 2 times m plus 1 equals to 0. This gives us m plus 1 into m plus 1 by 2 equal to 0. Now equate each factor to 0. M plus 1 equals to 0 and m plus 1 by 2 equal to 0. From m plus 1 equals to 0, we'll get m equal to minus 1, and from m plus 1 by 2 equal to 0, we'll get m equal to minus 1 by 2. So the roots are m equal to minus 1 and minus 1 by 2. Therefore, m equal to minus 1 by 2 are the real and distinct roots. The roots are real and distinct. We know that when two roots are real and distinct, say m1 and m2 are real and distinct roots, then the solution to homogeneous equation looks like y equal to c3 some constant into 1 root into x plus another constant into e power another root into x. Here I am taking c3, c4 instead of c1 and c2 because I want c1 and c2 to appear in the last general solution. Now coming to the solution to equation 4, that is a homogeneous equation. The solution to homogeneous equation is y equal to c3 e power 1 root into x plus c4 e power another root into x. This gives us c3 e power minus x plus c4 e power minus x by 2. Therefore, y equal to c3 e power minus x plus c4 e power minus x by 2 is solution to our homogeneous equation. Now, using this solution, we'll write the general solution of our problem. Let y equal to, just replace the constants or parameters with some functions of x, say a and b. We'll have a e power minus x plus b e power minus x by 2. B, the general solution to our problem or to given equations, we can say, where a and b are functions of x. Right? Now, we can compare the solution to homogeneous equation with y equal to c3u plus c4b, or this with y equal to au plus bb, so that we'll get u and b, where u is e power minus x and b is e power minus x by 2, or u is e power minus x and b is e power minus x by 2. We'll have u equal to e power minus x and b equal to e power minus x by 2. So here we'll find a and b using a dash and b dash. A dash is given by minus v into r of x by u v1 minus vu1, and b dash is given by u into r of x by u v1 minus VU1. If you notice, we are having UV1 minus VU1 in both the formulae. So we'll begin with UV1 minus VU1 and later we'll find A dash A, B dash B, and finally we'll put A and B in this to find the given, general solution to the given problem. Now coming to UV1 minus VU1. V1 is nothing but derivative of V. U1 is nothing but derivative of V. This is equals to U e power minus x into V e power minus x by 2 dash minus V into U dash. This is equals to e power minus x into, we know that derivative of e power ax is a into e power ax, right? Then for a equal to minus 1 by 2 we'll get minus 1 by 2 into e power minus x by 2 minus e power minus x by 2 into minus 1 into e power minus x, right? This gives us e power minus x into minus 1 by 2 e power minus x by 2 minus into minus plus e power minus x by 2 into e power minus x, or you can write directly, okay? See, e power minus x into e power minus x by 2 repeating twice, so let's simplify it. You can just write this as e power minus x by 2, which gives us e power minus 2x minus x by 2, which is e power minus 2x minus x is minus 3x by 2. This gives us minus 1 by 2 into, replace e power minus x into e power minus x by 2 with e power minus 3x by 2. You'll get minus 1 by 2 into e power minus 3x by 2 plus e power minus 3x by 2. Just take e power minus 3x by 2 common from these two terms. We'll get e power minus 3x by 2 into 1 minus 1 minus 1 by 2. 1 minus 1 by 2 is half, or 1 minus half is half, you can say. This gives us 1 by 2 e power minus 3x by 2. Therefore, UV1 minus VU1 equal to 1 by 2 e power minus 3x by 2. Now coming to A dash. A dash is given by minus V into R of x by UV1 minus V1, right? Is equals to minus V e power minus x by 2 into R of x e power minus 3x by 2 by UV1 minus V1 is 1 by 2 into e power minus 3x by 2, right? This gives us minus 1 by 2 into e power minus x by 2 into e power minus 3x by 1 by 2 into e power minus 3x by 2, where 1 by 2 gets cancelled, we'll get minus e power minus x by 2. We can write e power minus x by 2 into e power minus 3x as e power minus x by 2 minus 3x by e power minus 3x by 2. Okay, this gives us equals to minus e power minus x by 2 minus 3x gives minus x minus 2 3 is a 6x by 2, which is minus 7x by 2. Okay, we'll get e power minus 7x by 2 by e power minus 3x by 2. You can write this as e power minus 7x by 2 into 1 by e power minus 3x by 2. Reciprocal of e power minus 3x by 2 is e power 3x by 2, right? This gives us e power minus 7x by 2 plus 3x by 2. We'll get minus 7x plus 3x by 2, which gives us minus e power minus 7x plus 3x is minus 4x by 2. which gives us e minus e power minus 2x. Therefore, a dash equals to minus e power minus 2x. We got a dash. Let's now find a. We have a dash equals to minus e power minus 2x, right? A dash is nothing but derivative of a with respect to x. Now let's separate the variables by taking differential dx to RHS. We'll get dA equal to minus e power minus 2x into dx. Here the variables are separable, so we need to perform integration. Integral dA equal to minus integral e power minus 2x dx. Since we know that integral d theta equal to theta and integral e power a theta d theta equal to 1 by a e power a theta. This gives us integral dA equal to minus, for theta equal to 2, a equal to 2 and theta equal to x, will have minus or 1 by minus 2 into e power minus 2x plus some integral constant, say c1, which is equals to 1 by 2 e power minus 2x plus c1. Therefore, a equal to 1 by 2 e power minus 2x plus c1. Let's now find b dash and b. B dash is given by u into r of x by u v1 minus v1 is equals to u e power minus x into r of x is e power minus 3x by 2 by u v1 minus v1, 1 by 2 into e power minus 3x by 2. You can write the numerator as 1 by 2 into e power minus x into e power minus 3x by 1 by 2 into e power minus 3x by 2. 1 by 2 gets cancelled and we can write the numerator as minus x minus 3x into 1 by e power minus 3x by 2, which gives us e power minus x minus 3x is minus 4x, and reciprocal of e power minus x by 2 is e power 3x by 2. You can write this as, right? Just simplify minus 4x plus 3x by 2, which gives us minus 4 to the 8x plus 3x by 2, which is equals to minus 8x plus 3x is minus 5x by 2. Just replace minus 4x plus 3x by 2 with minus 5x by 2. We'll have e power minus 5x by 2. Therefore, b dash equals to e power minus 5x by 2. Let's now find b. We have b dash equal to e power minus 5x by 2, right? B dash is nothing but derivative of b with respect to x. In order to separate the variables, we'll take the differential dx to RHS. We'll get db equal to e power minus 5x by 2 dx. Here the variables are separable. So we can perform integration. Since we know that integral dx equals to x and integral e power ax dx equals to 1 by a e power ax, right? Then this gives us integral db equal to b, and for a equal to minus 5 by 2 we'll have integral e power minus 5x by 2 can be written as 1 by minus 5 by 2 into e power minus 5x by 2 plus some integral constant, say c2, right, which is equals to minus 2 by 5 e power minus 5x by 2 Plus integral constant say C2. Therefore B equal to minus 2 by 5 e power minus 5x by 2 plus C2. So we got A and B. Let's now find the general solution using y equal to a e power minus x plus b e power minus x by 2. Therefore, the general solution is given by y equal to a e power minus x plus b e power minus x by 2. Substitute a and b. We have a 1 by 2 e power minus 2x plus c1 into e power minus x plus b minus 2 by 5 e power minus 5x by 2 plus c2 into e power minus x by 2, which gives us 1 by 2 e power minus 2x into e power minus x plus c1 e power minus x plus into minus minus 2 by 5 e power minus 5x by 2 into e power minus x by 2 plus c2 e power minus x by 2. Just simplify e power minus 2x into e power minus x and e power minus 5x by 2 into e power minus x by 2. This gives us e power minus 2x minus x, which is equals to e power minus 2x minus x is minus 3x, and here we'll have e power minus 5x by 2 minus x by 2, which gives us e power minus 5x minus x by 2, which is e power minus 6x by 2, which gives us e power minus 3x. Right? The above equation becomes 1 by 2 into e power minus 2x into e power minus x can be replaced with e power minus 3x plus c1 e power minus x minus 2 by 5 into e power minus 5x by 2 into e power minus x by 2 can be replaced with e power minus 3x plus c2 e power minus x by 2. Or we can write this as c1 e power minus x plus c2 e power minus x by 2 plus 1 by 2 e power minus 3x minus 2 by 5 e power minus 3x. This is equals to c1 e power minus x plus c2 e power minus x by 2 plus, take e power minus 3x common from these two terms, we'll get 1 by 2 minus 2 by 5 into e power minus 3x. Just simplify 1 by 2 minus 2 by 5. LCM of 2 and 5 is 10, right? The numerator of first term you're having 2, so close 2, and multiply this 5 to 1, you'll have 5, minus in the denominator of second term you're having 5, so close 5, and multiply this 2 to the numerator of second term, you'll have 2 into 2, 4, which is equals to 5 minus 4, 1 by 10. This becomes y equal to c1 e power minus x plus c2 e power minus x by 2 plus 1 by 2 minus 2 by 5 is 1 by 10 into e power minus 3x, which is the required solution. Therefore, y equal to c1 e power minus x plus c2 e power minus x by 2 plus 1 by 10 e power minus 3x is the required solution. So we have seen a problem from variation of parameters method in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.